open up my notes right here, I can begin. So, this scene right here, if I press play, the mouse button, can go around the scene and kind of, instead of those ugly flame circles, I can gather these floating boxes, and it's basically done in Blender. Oh, missed one. Where's that one? Oh no. Anyway, missed that one. So it's those boxes are done in Blender and imported in Unreal. And basically, once you're done with the race, you just kind of go into this kind of nice forest and then take a look at the beautiful trees and understand that it doesn't matter how cool the architecture looks like, a forest is much prettier always. You know, it's the nature is this calm and soothing environment, not that, right? Either way, that was just a small little test of me checking out how the whole environment might look like and working with, you know, some fog effects, some light effects, and so on. So that's the pure breakdown of it. If I zoom out, it's just a landscape, right? Some trees, some flowers, and so on. The building itself, and some checkpoints, right? Those floating boxes. That's about it. And also, I just added two. How's it called? I keep forgetting. Sorry, volume. Something about volume. Something volume. Post-process volume. PPV. So post-process volume is where you kind of control the brightness, the contrast. You can control the bloom of things, and so on. So it's basically these boxes here. And I have two of them. You don't really need two of them. I just added two because I want the inside to be a little bit more reactive to light, right? A little bit brighter. Oh, there's people waiting in the admit all. There we go. So basically just those post-process volumes, they just create, they just override the camera settings once you are inside of them, right? Inside of these boxes. Either way, can I just walk away from, yeah. So this is my little environment here and my test polygon. Okay. So now, let's start by working with checkpoints, right? Me showing how to work with checkpoints. As they are right now, that's my checkpoint, and let me delete all of them. Delete, except the last one. Yes to all. There we go. Sorry, except the first one. Or did I say the last one? I don't know. I'm losing my mind. So let me move it to the side here. So this is, let's look at it. This is a checkpoint. Basically, the way it works is it's a box, like a flat box. Once you pass through that box in this direction, where the red arrow is pointing, so you can't pass through the box other way around, right? So you need to pass it through in this particular direction where the red arrow is pointing. Once you pass through it, the checkpoint is considered to be checked, right? And then the next one will appear. So this is what I was talking about, like adding breadcrumbs in your interior space to guide the viewer or the visitor to go through the path that you want the viewer or visitor to take, right? So I have deleted all of the checkpoints except the first one. You can see here in the content browser, no, World Outliner, content browser, I believe is in Blender. in the world outliner. I have only one checkpoint left. And let's see its insides, what's happening inside of the checkpoint, right? So if I click on Edit Checkpoint, this link, I guess, right here, if I click on that, it will open up what's called a blueprint of the checkpoint, right? So the blueprint is basically a script that's working underneath it, right? That's under the hood. What's going on here, and basically in this script you don't need to change anything. Later on we will kind of go into it just a tiny bit and just tweak a few things, but it's not going to be, this is done, right? It's unnecessary for you to mess around with it. This was something that I've done just to kind of, it has nothing to do with architecture, thus I am not teaching you this. I am just kind of preparing the material for you to use in this case. So that's the event graph. You also have two more tabs here in the checkpoint blueprint. Event graph is what happens. Construction script is basically how is it built, but here it's empty, so we don't add any information to the construction script, and we won't need to. And also there is the viewport. This is how it looks like. And what kind of components does it have? So you will see something like, where is it? Hello, looping, no. I'm just trying to, yeah, there we go. So you will see something like this, right? Basically, there will be three components in here that make up a checkpoint. First one is an arrow, which is basically just a direction. I can't really... can I? Sure. So the first one is an arrow, which is just basically a direction of the checkpoint. Don't mess around with that, please. Second one is trigger, which is basically just a box through which you need to go. It's not visible in the game. It's just something, you know, invisible that is being kind of used to mark out if a character has passed through this checkpoint. And the third one is the particle system, right? So here the particle system is fire, but you can also have like, okay, explosion just happens once. Sparks, for instance, right? So you can have a sparks particle system. Honestly, we will not be using neither one of these particle systems because they're too, in my opinion, they are too cliche and too kitsch. So what we're going to do is we will select the particle system here on the left-hand side. Then we will go right to the right-hand side, which is basically all of the details of that particle system. And we will find where it says rendering and it says visible. So we will untick visible. So it becomes invisible, right? So that's that, right? We just hidden the sparks. If I now press compile, compile means basically calculate. Let's call it calculate. Compile is calculate. So if I press compile and I press save, then and I open up my main map, then I can see that there is nothing happening in the checkpoint. So the checkpoint, since it doesn't have any geometry representing it, it's invisible, right? So that's that. Now how to add some fun stuff to the checkpoint, right? I showed you the floating red box, but perhaps we can do oh wait, there's chat. Frederick is in the waiting room, not anymore, I think. Or is he? No, he's here. So how to import animation, mesh animation into Unreal, and also not just that, but also how to link that animation into the checkpoint and use it as, you know, as some sort of a component inside of the checkpoint. So let's do that. I will open up Blender, actually, because it's much easier to create animations in Blender than it is in Rhino. You can still kind of do it in Rhino, but in my opinion, it's much, I mean, for just these type of animations where it's kind of Euclidean transforms, XYZ movement, XYZ rotation, XYZ scaling, and so on, it's much better to just use Blender. And so let me hide that. And I will actually use the cube, or we could go fancier with this. No, let's use the cube. So I'll use the cube. I will get rid of the camera though, and I'll get rid of the light. So I only have the cube here, like so. I will add a modifier to the cube, which is going to be, can we go for Bevel? Oh, actually, before we do that, before we add a modifier, let me show you one thing. If we select this cube and we press S for scale, Z for Z direction of scaling, and then just 2, enter, so we scaled it up 2 times, or actually you can do SZ3, so scale it up 3 times, just in the Z direction. And then we add, let's say, a bevel modifier to it, which chamfers the edges, right? You can see that the edges in the top and the bottom are being chamfered more, or are being stretched compared to edges on the sides. This happens because I just Ctrl Z, like undid it. This happens because the cube remembers that you scaled it, and it records it. It records how it was before scaling. It records that you have stretched it, right? And then when you add a modifier, it actually adds the modifier to the original cube and stretches the beveling or the chamfering. It stretches also 3 times in Z direction. So that is something that is not counterintuitive, but if you're used to Rhino, when you scale geometry, it just changes size, right? When you scale geometry here, or when you move geometry, it remembers the transforms, right? So it's something that you need to be mindful of, and to get rid of that, to say that, well, actually this geometry is now the good one, the original one. You select the object, you go to Object here in the top, you click on Apply, and you find all transforms. So you just basically apply all of the transformations to it. So now, if I were to press N, I can see that the scaling is 111. Rather, if I Ctrl Z it, it was 113, right? So 3 in Z direction. And when I did the apply all transforms, it made it 111, which means that now when I add a bevel modifier, it's clean, right? It works nicely. And I can kind of mess around with it, increase, decrease, it doesn't matter, add more segments to get it more rounded, or anything like that. Actually, we can kind of... let me just do 0.2 meters and segments 5. I think that's okay. And I'll just apply the bevel modifier. Okay, so that is done. Now, one thing that I need to do is I need to make sure that these polygons are not so much in your face. So there is a difference between hard surface shading and soft surface shading. So if I select my object in the object mode, right click on it, I can choose either shade flat or shade smooth. So right now it's being shaded flat, meaning every polygon gets its own, not a light source, but the angles between the polygons are considered to be sharp. I can right click and choose shade smooth, and now they are soft, right? So that's just a quality of life improvement. Okay, let's animate this one. So I will say, first of all, I need to decide how long is the animation. So I will say 120 frames. I think that's reasonable. 120 frames, and for frame 0, I will just press the end button, and I'll just, on hovering my mouse over location, rotation, and scale, I'll just press the I button. I is basically insert keyframe. I stands for insert. So I. Basically just creates, let me just move it here so that you can see better. It just creates this keyframe here. Then I will move to perhaps 60, and I will say, or rather let's do 30. And then I will say that sorry, not I, but the location should be higher, right? So G, Z, and I'll just move it up by 2, I don't know, something like that. Maybe that's a little bit too much, but it is what it is. So now it kind of just moves from here to here, right? So I keep pressing I on the transforms to add the thing, add the keyframe. So that's 2, and then let's say 60 more frames. That is going to become -2. I again. So now it's doing that. And then at 120 frames, it becomes 0 again. So Z0I. Okay, let's play it. Wow, wow, wow. That's a shitty one. So let me try. Wait, how do we make it nice? So that is 2. It needs to stop and go, but it shouldn't slow down here, right? So there is this kind of softening of the animation. You can see that it starts going, like it increases in speed and then decreases in speed once we get close to the keyframe. And this is something that's called keyframe interpolation, or whatever I believe it is. Yeah, interpolation mode. So if I select the keyframe, right click on it, and choose interpolation mode to be linear rather than Bezier, it will basically say that there is no increase or decrease in speed. It's always, the speed is always constant, right? So now I think all right. that doesn't work. This is, there we go. That's what I, please work. No. Okay, fair enough. I will just select all of the keyframes, delete them, and we try again. But this time around, we first move the Z of the box to -2. So we will start from the lowest point of the box. So -2, I. Then we will go to +2, which is going to be at 60, +2, I. And then 120 is going to be -2 again. So I'm kind of evading the 0 coordinate, right? I'm jumping around the 0 coordinate, and also I have less keyframes. Now it should be fine. Yes, now it's looping properly. So this is something to be mindful of, is that transition. When the animation loops, that transition is quite important to keep smooth. There's one more workaround which you can do in the animation tab. If you select this little icon here, you can choose the graph editor, and here you can actually mess around with the speed curves, but I don't want to do that, so we will not, because that would take way too long. So it's just kind of floating up and down. We can introduce rotation as well. So let me say it starts from 0, and then it kind of ends the rotation. Z is 360 degrees, like that. So it's kind of doing this thing. Right. All right, so it's doing that, and now let's add one more rotation, and then we will call it a day. So let's say it starts rotation in X also is 0, but then it goes to like 90 here, and then it becomes 0 again. Okay, that's good. Well, not the best, but you get the idea. Okay, so we have our animation done, and now it's time to export it, right? So the format that you use to export animations from Blender is FBX. You just select the form, make sure that it's the only thing that you have in the scene, that you don't have any lights and anything like that. You go to File, Export, FBX. Here there is a bunch of settings. I'm sorry, a bunch of settings, and I don't remember if these are okay. X-axis only deform bones. Add leaf only right deforming bones, and non-deforming ones will be have deforming children. That's fine. Normals only. That's fine. I think using standard, yeah, I think standard values will be fine. If they don't work, then I will need to kind of investigate a little bit, but I think standard values are fine. If you have more than one object in the scene, and you don't want to kind of have separate file for every separate animation, you can choose this limit to option where it says selected objects, right? So if you tick mark this, only the objects that you have selected will be exported. So that's also kind of useful. Let me go to desktop, stuff, resources, Unreal Engine stuff. I already have like floaty box here. So I'll just write floaty long boy, floaty long boy. That's the settings. Export FBX. Let's just see if it doesn't give us any errors. Doesn't seem like it gives us any errors. So that means we can go back to Unreal Engine, go to our content browser. Or should it be under geometry? Let's just create a new folder. So I'm going to content browser, geometry, and I'm just creating a new folder. I'll call it floaty long boy. There we go. Just so that I have where to put the FBX file in. And then I can go to File. Wait, is it? Do I just drag and drop it in? No, I go to File, Import into Level, and I'll find my my just created animation, wherever it is. There we go, Floaty Long Boy. For some reason it's super small compared to... Wait, my camera is lagging, everything is lagging. Anyway, so it's super small compared to the just the original one. We'll see. I'll just click open and let's see what happens. So it's the first thing it does, it asks me for where do I want to upload it to. So I'll go to Geometry, Floaty Long Boy. That's my folder. Hit OK. And here I'll have my whole like settings dialog, where it basically just shows me what we have: skeletal meshes, static meshes. Sorry, I'm just really quickly checking out if everything is fine. That's actually fine. Create content folder hierarchy, import as dynamic. Maybe we'll need that, we'll see. Yeah, actually, yeah, sure. Let's just try. Import. It's going to take a little bit of time. No smoothing group information was found. Skeletal mesh don't have a bind pose. Imported bone transform is different from original. Please check output log to see detail of error. Okay, so it does give us a few warnings. So these are not errors, these are warnings. Let's just see if it's still a problem. So let me close that. So here we have cube skeleton, floaty long boy. Okay, and then we have the cube. So we have a lot of stuff going on here, like a lot of geometry was imported. So we need to investigate which one is what. Well, that's my bad. Accidentally brushed on some flowers. So we will need to investigate, oh my god, a little bit laggy, sorry, which one is which. So to do that, yeah, okay. So to do that, I will start hiding things actually. So let me hide the test model. Just grab that first person character and just move him down. Just here. As you can see, since my light is baked, since my light is built, the shadow of the hidden geometry still stays. I will need to rebuild it so that it doesn't stay, but that's fine. Is it possible for me to hidden in game? Okay, that should be fine. Let me just press play and check. It's not fine. It's actually breaking. It's not breaking, it's just, it's not hiding the geometry which I want to hide, so I'm just going to move away my character to some sort of a further away location. Right here should be fine. Yeah, that's good. Okay, so back to FBX import. We have cube, cube animation, for some reason 2 of them. Why do we have 2 of them? Import data, skeleton, and so on. So I will just drag the skeletal mesh, this one right here. I'll just drag and drop it in to my scene right here. And it's not... Why are you not showing up? Oh, you are. You're just super small. Okay. So it's just, it took what was in meters in Blender and it translated it into centimeters in Rhino. This is not Rhino, hello, this is Unreal Engine. So what we're going to do is we'll just select this and we will scale it up to 50. Maybe that's a little bit too, no, it's big, but that's fine. We can mess around with the scale of it later on. So I'm just kind of selecting it and scaling it by 50, right? Right, so this is our thing, our element. But if I press play, you will see that it's not actually animating, right? It's just our shape. You know, just a box. So how do we add? Yeah. It's complaining because I've deleted all of the checkpoints. We will come back to the checkpoints in just a second. So the reason why it's not animating is because there's no animation attached to it, because what Blender export did, it created a separate skeletal mesh, which is the pink underlined icon here, and it created the animation information, like animation sequence, as a separate entity. So when I select this cube and I scroll down here somewhere, oh, there we go. When I scroll down here, there's an animation tab. It's actually right after the scale, animation tab. And here I need to say not use animation blueprint, but rather use animation asset. So by the way, assets are every component, every little thing that Unreal Engine can reference. So assets can be materials, can be meshes, can be foliage, can be textures, and so on. Those can be sounds. Those are assets. It's an umbrella to call many things in one word. So use animation asset. I choose that. And then it asks animation to play, and I'll just grab cube animation, this one right here, plug it in there, and that should be that. If I press play, wonderful! It's not playing. That's what I. This is what I love. Okay, great. Always enjoy this when things are not working out. What about the second one? Are you also not going to play? It is playing here though. Like if I change the initial position, it is playing. Let's try again. Oh, okay. My bad. So for some reason, for me it created two animation sequences, and now I know that the second one is the correct one. The first one for some reason doesn't have any, it's redundant, it's unnecessary. So I'll just so that I don't need it, I'll just don't accidentally use it, I'll just delete it. Blah 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 blah, force delete. What's the worst that can happen? It crashed. Well, wait, no, it didn't crash. It's doing something. Oh, this is such a ghetto tutorial. Let's give it some time. If it crashes, then we will have a 5-minute break for me to re-import everything. Seems to be good. Play. It's floating. Everything's fine. Okay, we're good. And I can kind of go to here. You can also, like for the static mesh, you can add collisions and so on, just like we did with any other mesh. So this thing can bump you as well. Please don't add collisions to the checkpoint. I don't think that would work. You just try to go through a checkpoint and you kind of bump into it. But anything else, if you have any moving parts in your building, then this is the way to do them. Right, so we have our floaty boy here. Yeah, I need to cancel those. Material, right? I want it to glow. I don't, well, right now I do have a glowing material, which is right here, the emissive one. And I can show you how it looks like, and we will kind of quickly rebuild it so that you so that you can see how it's built, right? So let me actually place it here. For now, I'll just close the checkpoint blueprint. We will come back to that in just a second. So material. I'll go to my materials folder, right-click on it, and choose a material, just straight up. We create a new material, and I'll call this Emissive 2. Right? Because that's the second one that I'm going to make. And I'll just double click on it. Right? So now we're editing it. So emissive material. It asks me for a bunch of inputs, but the main ones are base color, roughness, and emissive color. So these three inputs. Base color is basically if your material at certain point will stop shining light, what kind of color will it have? You know, for instance, if you have a light bulb and you turn it off, what kind of color does it have? Second one is roughness. It's basically when you turn it off, when you turn off the light, is it reflective? Is it glossy or is it not? Right? So that's roughness. And third one is emissive color. It's basically what kind of color does it shine and how strong is it? So here I have created these like a super simple starting point for controlling the emissive materials. And it's basically, well, let's do this. So roughness is a straight up a number, nothing more than that. Right? It's a number between 0 and 1. 0 meaning it's completely glossy, 1 meaning it's not, it's completely matte. So roughness, I will drag out of it and I'll type in scalar parameter. Right there. Or is there like a better version? No, there's not. I'll give it a number, sorry, I'll give it a name. I will just call it roughness. So now you can see when I add roughness as 0, just a second, Felicia, I'll answer that. I see your message. So when our roughness is 0, it's a very glossy material. When our roughness is 1, it's going to be a completely matte material. I believe this is already working, yes? Who knows? So it is completely matte. Let's just see 0.5. Oh, it took a while to calculate, actually. While we wait for it to do its magic, Felicia asks, do you think it's better to add material to an object in Blender before exporting or afterwards in Unreal? Depends. Super depends. If you are doing like character design, like if you're creating characters, then you can, okay, let me phrase it this way. If you create a material in Blender and you import it into Unreal, if you import the model with the material into Unreal, some things might be lost right, in the process, because it still needs to translate information from Blender's materials to Unreal materials, but you will have a starting point to work with, right? So you will probably see that, oh crap, bump map is missing, right? Instead of bump map, I need to use some sort of a normal map, right? So then you will need to kind of work around that problem. So that is the main issue with losing information. But I would probably, if it's a super custom material that you definitely, like you kind of made it in Blender and you really want to keep it the way it is, then I would try to import it together with them all into Unreal and just fix it rather than rebuilding it from scratch. There's also an alternative where I showed you texturehaven.com, where you can just download materials, and those materials are straight up used in, they are used for Unreal. So those textures rather are used for Unreal. So that might also be a good alternative, right? Having a library like that. Either way, that's 0.5 roughness, right? So kinda glossy, kinda not. Let's go back and see what else do we have here. So base color, you can just change the color, right? So base color, I will drag out of it, and basically now I need some sort of a color picker, right? Some sort of way of how to choose a color, and that is called, how is that called? Vector, something about vector. Vector 3. There we go. Is it though? There we go. Constant 3 vector. Yes. For some reason it gives me it under constants and under vectors. Maybe that's expected, but this is what you get. I just wonder, is it possible to just write that? No, it's not. Okay. just wanted to make sure. Or can we just write 3.3 particle? Vector param. What if we do vector param? Ah, yes. So you can either do, there's two versions. The one that Max was, I think it was Max, at least from the voice, I think it was Max, who said that you can use a constant 3 vector, which is basically like 3 values, and those 3 values translate to color, right? RGB, red, green, blue. So you just select it and you change the constant to, let's say, red, and that's it. Right, so now it's red, and now it's going to update here, and then it's going to update here, straight up. But the thing that you get from it is just the RGB color, just the color. So for this particular instance, it's perfect, right? As simple as it can be, and you don't really need to mess around with it. The problem with it is that you can't change, if you create a material instance, right, of this material, you don't get that nice slider that you can change the color of, right? So instead what I use is called vector parameter, or I already forgot. Vector parameter, yes, vector parameter. And where it says parameter, it means that you will be able to change it in real time in Unreal. So that's also quite a nice thing, and I'll just call it base color here, connect it as my base color instead of that, because I will want to be able to change it. And I'll just make the base color whatever, blue. Sure, that's fine. Okay, so that is that. Then the last one is emissive color. And for emissive color, it's basically a color plus brightness, or rather a color multiplied by a number which represents the brightness, right? So we need a vector parameter again, vector parameter, and I'll call it emissive color, right? Oh, by the way, these outputs here is you can get separate channels for RGB and alpha, right? Just so that you know. So I get an emissive color, and I'll make it some sort of a reddish, pinkish reddish color. Why is it? What the? Anyway, I'll make it pink, sure, pink color, and I will multiply it by a number, a slider, right? So I'll extract, not extract, but extend from it, and I'll write multiplication or multiply. So I have multiplication going on, and I will multiply it by a scalar parameter again. Again, scalar parameter equals number slider. That should be in your head. And I'll call this strength. Strength, straight up. Connect that to emissive color, and you have yourselves a material which doesn't shine light because my strength is set to 0. Forgot to do that. So let's say our minimum slider is going to be 0 and our maximum slider is going to be like 50, and default value, let's just do like 10. So I just select that slider and just gave it bounds and gave it what's the default value. Yay, pinky. Okay, we click save. We have saved our material, or at least we're trying to save our material. And you'll see that since I'm using parameters, like 4 parameters here, once I do the next step, which is taking this emissive material, right-clicking, and choosing to create instance, create material instance. Remember this one? Create material instance, and I won't even rename it. I'll just leave it as emissive2 inst. Right? Now, if I double-click on the material instance, I can see those parameters right here: base color, emissive color, roughness, strength. So now I can mess around with the strength, right? I can mess around with the roughness. Well, you can't really see the roughness, so let me turn off the strength, and so that is negative roughness, apparently. Let me just leave it at 0. I can mess around with the base color, right? And I can also mess around with the emissive color, but for that I actually need strength to work. So that, and let's just make it blue, right? So now it's blue. Let's make it yellow. Now it's yellow. So this is why we do a master material and material instance. Because now from that master material, I can make like 50 instances, right, with different colors. And it's just going to use the same master material, but it will have 50 variations of it. So instances are great. Okay, so we have that. Let me just save it. Actually, let me kind of minimize it in this way, because I will be adding it to this box, right? So I have my emissive2 instance, and under materials here, I'll just drag it and place it here, and then wait 50 years until it kind of calculates. Come on, you can do it. What if I click save? Oh my god. There we go. So it did it. And now I can, for instance, increase the brightness of it, or completely decrease the brightness of it. Right? I can do that. I can change its color almost in real time. You can, by the way, animate these things as well in the material editor so that it kind of blinks and changes color and so on, but those are just special effects that I don't feel like you need, but you do need to know how to make a shiny lamp, right? So that's why I'm showing you how to create an emissive material. Okay, so we have this one. Let me press play. There it is, floating in space. Take a look at it, and it's doing its thing. All right, that is, that's a lot of errors. We will fix those. So that is done with this element, and I am actually going to do the unthinkable and just delete it, because I now have all of the components of it, and I know where I'm going to be using it. It's actually going to be, wait, where's my, did I delete my, no, I still have my checkpoint. By the way, if you have an object in your scene, but you can only find it through the world outliner on the right-hand side of the screen, you can select it in the world outliner and then press the F button to focus on it, right? So the camera will move to it. So there's our checkpoint. And I want to add that floaty box in here, right? So I'm going to edit checkpoint again to access its blueprint, like that. And I'll go to the viewport. And actually, let me get rid of the old skeletal mesh. So this is what you will see right now, right? We have already hidden the particle system, so you don't see it anymore. But this is what you kind of will see. We need to add the floaty box inside of it. So I will choose to add component here in the top left corner, add component. And this is basically all of the different things that you can add to the to the checkpoint. So it's a lot of things, and it takes a while to find the correct one. But basically the one that you want is called Skeletal Mesh. Static mesh means it's not animated. Skeletal mesh means it's animated. That's about it. Skeletal mesh, you can call it anything you want. I will just keep its name as skeletal mesh. That's fine. And here on the right hand side, then once I have it selected, on the right hand side I can start adding the skeletal meshes. Or not the skeletal meshes, the skeletal mesh, the actual box, right? So let me find it. It is going to be my cube, which I haven't changed the name of, so it's just going to be my cube, like that. And I can't see it. I can't see it because it's so super small. So let me just, where it says scale of transformation, also on the right hand side, let me also increase it here, 50. Okay, maybe 50 is a bit, wait. No, 50 is 50 too big? Let's do 30, just so that it's not too big. And I will just move it down a bit because I know that it floats up, right? So I have it doing its thing here. Then for it, I need to also repeat the same steps that we've done so far. So I will, under animation mode, I will change this to animation asset, and I'll find my animation asset. I think it's this one. If I hover over it, I can see its path, and the path is floaty long boy. So yes, it is this asset right here, like that. It starts floating. And now I can kind of position it in a nice way so that it's... Yeah, that's good. By the way, the gumball things, the arrows and the rotation and so on is, again, located here in the top of the screen. So you can rotate, scale, and do whatever you want with it. Okay, so we have that. And the last one is material. So we just choose, let me just type in emissive to instance. Emissive to instance, this one. Yay, pinky. Yay, okay. So this is right now us changing the checkpoint and changing the format of the checkpoint. Let me compile. Let me click save, but I will not close the checkpoint. I'll just go to the level and just see how it looks like, and it's looking fine. It's looking decent. Let us do a few more things with the checkpoints, and then we will have a quick break. Or maybe we should have a break now. Well, let me just quickly move it to the bottom. F. Oh, it's way too. It's below the landscape now. Perfect. Zoom, zoom, zoom. I'm just trying to move it closer to the character, so that I don't need to wait too long. Like that. Let's press play and let's just see what happens. So we have this, and then I believe if I go through it, yeah, it doesn't disappear, nothing changes, you know. It's not reacting, but at least it's working as a, you know, as an animation inside of Unreal, even though here it's there's a few problems, but we will be fixing those in just a second. Okay, let's. My voice is going to town, so let me quickly stop the recording for a bit. There we go. So coming back here to our little checkpoint, right now there's a few problems. First problem is it's not reacting to anything that we do with it. Second problem is it's not, well, I guess it's a part of the first problem, is when we pass through it, it doesn't disappear. We want it to disappear, right? We eat the breadcrumb and we kind of continue on. So back in edit checkpoint, in the blueprint of the checkpoint, back here, there are two things that we need to fix. The first one is if we scroll down here, under rendering, on the right-hand side, there is the visible. This is super dark and like Swedish autumn. Wonderful. Okay, there we go. Nice bright light. So in rendering, you can see that it's turned to be visible, but it's turned to be not to be hidden in game. Think of it this way. Let's say we have 2 checkpoints, or let's say we have 50 checkpoints, right? You don't want to show all of those 50 checkpoints all at the same time, right? And then as you move through each one of them, they kind of disappear. Rather, you want only the first checkpoint to be shown first. You move through it, the first checkpoint disappears, and then the second one appears, right? And then you move through that one, then the second one disappears and the third one appears, right? So you want to have that sequence rather than seeing all of the checkpoints at the same time. So what we're doing is, what we need to do is we need to choose that the checkpoints originally are hidden in the game, right? So I will tick mark that, hidden in game. That's important to have tick marked. And then I will go to the event graph, what happens with the checkpoints, right? Event graph. I'll zoom in here. And here you can see set hidden in game. So it's counterintuitive. Here it says set hidden in game, but rather it's unhided. Or rather, maybe, wait, checkpoint numbered, call checkpoint cleared. No, it's actually that. So this event graph here, where it says set hidden in game, this part represents when we pass the checkpoint that it needs to become hidden, right? So if I were to break it down, once the character moves through the checkpoint at precisely, not precisely, but at kind of the same direction as the arrow is pointing, right? Once the character moves through the checkpoint as the arrow is pointing, it should call this function that is, the checkpoint has been cleared, right? And when it calls that function, then that particular checkpoint needs to become hidden, needs to disappear, right? So here, it's what's being hidden is the particle system. But we're not dealing with the particle system anymore, right? We are dealing with the skeletal mesh. So we need to hide the skeletal mesh as well. So how do we do that? Well, for every component here, there's a function associated, attached to it on the bottom left-hand side. So in the blueprint, there is components, and here we have particle system, trigger, arrow, root, don't care about root, and skeletal mesh. This one was created once we imported our box into the checkpoint. So what we do is we just take it and we drag it into the screen, and I believe it's set skeletal mesh. No, it's not. Oh no, oh no, now I'm, oh, my camera is dying. Don't die. Here we go again. If it starts dying, I'll just switch to my other camera. Okay, so it's not set and not get. How do we? Oh my god, now I'm lagging. Let's try it this way. So instead of dragging it from the left-hand side to the screen here, let's just try to drag out a wire from the target where the particle system goes in, and let's type in skeletal mesh, get skeletal mesh. Oh, actually it is get skeletal mesh. That's it. That's all we need to do. So now, even though we're not using the particle system, it's still going to be hidden. So this is not perfectly optimized, I know, but I don't want to deal with that right now. So let's just have some, trash from before working here. But now the skeletal mesh is also going to become hidden. Once we're done that, we are done with the checkpoint blueprint itself. So all we did was just add get skeletal mesh here, and we messed around quite a bit in the viewport tab of the checkpoint. I'll click compile. It doesn't give me any errors. It just says compile of checkpoint successful, meaning we didn't mess anything up. I click save and I close the checkpoint blueprint. Let's press play. And let's just see if it actually at least hides. I don't think it will, but maybe it will. Yeah, it actually hides. Okay, so that works, right? So now every time when we pass it, it hides. Still a bunch of errors, that's fine. Now, we need to make more than one checkpoint. Duh. Well, the first thing that I'm going to do is I will scroll down here, and let me minimize that, and I'll find what's called the tracker. Tracker is basically the brain of the whole game. That's what it is. Oh, camera. Okay, let me do one thing with it, and we will... This is going to be awkward now. Like that. Close that. was a pleasure. Should be fine. Or not. Hello, camera? Camera. Oh my god, come on. Stop video. Start video. There we go. Okay. Making more than one checkpoint. So we deleted a bunch. We have only the first one. Let's make the second one. So tracker is the brains of the game, and there is a bunch of things that we will be able to change about the game in just a second. But for now, we are dealing with, we're going to tracker, and on the right-hand side, we're dealing with the checkpoints. So here you can see that only checkpoint 0 is marked out as an active checkpoint because we don't have any more, right? So what I'm going to do is I will actually delete. So clicking this small icon here, I will delete all other ones. So these are like empty slots where it's waiting for us to give it a checkpoint. And I'm just kind of leaving it with one, right? So now that is kind of fixed. Let's go back to our original starting checkpoint and let's make a copy of it. So how do you make a copy? Well, you make sure that you have movement, and not enabled, but movement handles enabled. Let's see it like that. Movement gumball enabled. And holding down the Alt key, just like in Rhino, hold and drag, and you have a copy of it, right? Let's make one more, just for the sake of it. Copy, drag, right? So we have two more checkpoints. The first one is called checkpoint, second one is checkpoint 2, third one is checkpoint 3. There's one important thing that we need to do, and is number them. And it's not the name that we're changing, but rather, let's say, when we look at the first checkpoint, it's actually the first slider that you can change. It's checkpoint number, right? It's that parameter there. So this is our first checkpoint, so checkpoint number is 0. Then this is going to be our second checkpoint, so checkpoint number 1. And this is going to be our third checkpoint, so it's checkpoint number 2. Yeah, starting counting from 0 is always fun, I know, but it is what it is. So 0, 1, 2. We change the numbers. Then we go to the tracker, where it says checkpoints, and we click on the plus sign. So we will add 2 more slots. Plus, plus. So checkpoint 0, 1, and 2. So now I will just choose checkpoint 2 as my second one, and I'll choose checkpoint 3 as my third one. I press play. Bam. And we go through it. Nom nom nom. All 3 checkpoints have been cleared, and the game should reset. Yes, the game resets, and we can try again, right? To play the game and make a better score. All right, so that has been done. Now, there are still some things that I want to mess around with within the tracker. If I click on Edit Tracker here, it will, actually you won't get that. You won't see that. So in your case, the previous step will not work as expected, but actually I can show you how it's not going to work. Let me just check if there's anything else that we need to work around. Just give me like 10 seconds. That's good, that's good, that's good. Update times, yeah, that's fine. Yeah, that's whatever. Compile, save. Actually, the thing that you will see is this, right? When you run it originally. And the reason why you will see it is because the brain, the tracker, doesn't know that it needs to show the first checkpoint. Right? It's not showing the first checkpoint. I believe if we kind of go through it, yes. If we go through it, we, at least I hear that it went through the first checkpoint, and the second and the third, but it's not showing them. The reason why it's not showing them is because in the checkpoint blueprint, we said that it needs to be hidden in game. And also we said that every time when you pass it, it needs to become hidden. But there's no option for us to say that, well, actually the first one needs to be shown in game, right? So this is handled by the tracker blueprint, and it's actually under, like, there's a separate tab called Activate Checkpoint, and it's right here. This will activate the next checkpoint, right? So next checkpoint at the start of the game is actually the first, you know, the starting checkpoint. So here, where it says particle system, instead we need to use whatchamacallit? I'll get there, a skeletal mesh, right? So now, just give me a second. I need my notes because I keep forgetting the name of it. Yeah, that's get skeletal mesh, right? So I will just drag out, or rather I can just right click anywhere on the screen and type in get skeletal, okay, it's not there. Okay, cool. What if I drag out a wire from here and type in get skeletal? Okay, sure. So when you drag out a wire from next checkpoint, it will give you get skeletal mesh function. Like that. And then skeletal mesh goes into target. And that's it. Get skeletal mesh. Compile, save, go back to the map, play. Good, everything works. Play. Yay. Okay. So that that's that. That is fixed. What else? Actually, nothing more. If you just need more checkpoints, so the way you work with them is you just holding down the Alt key, you kind of make a copy of them. And it's going to be a little bit more, oh, it's some nice lag going on here. It's going to be a little bit, not tedious, but positioning them inside of the building, inside of the structure is going to be challenging, but I believe in you. So you have the possibility to move them around, you have the possibility to rotate them, and so on. So you'll be able to figure it out, right? How to position them. All right, so that is that. Once you have created a new one, you do need to select it, and you do need to change the checkpoint number to a higher value. So in this case, it's checkpoint number 4. So checkpoint number is actually 3. And then you do need to do the add them in the tracker. New slot, checkpoint 4, there we go. That's good. So that is done. That is done. Okay, let me delete all of the things that I have already talked about. Particle system, activate checkpoint. Okay. Okay. So now, let me actually do one thing here. Can I just not save it? Don't save. Let me load up the Unreal game again, so that we're back to the original environment that I've shown you. because we were messing up so much with, not messing up, but breaking the game quite a bit. Oh, and you probably noticed that once we have done all of the steps that I've showed you, the error the error is also gone. Unreal doesn't give us any errors. So all of those errors were associated with the fact that we there were issues with checkpoints, either them not being shown or too many being referenced and so on. Oh no, did it actually autosave? Please don't tell me it autosaved. Did I just mess up my game? My environment? We'll see. Come on. Please be... Oh, yeah, okay, good. It's normal. There's some things here that are weird, but other than that, it's fine. Oh, right, we saved the blueprints. So I need to kind of... I need to fix the blueprints real fast, but that's going to take me like a few seconds, just a second. Skeletal Mesh floating box, use animation asset, that's going to be floating box animation. Emissive, yeah, emissive to instance. Viewport. Whoa. What the hell is going on? Oh, it's super big, okay. Scale 1. Scale 0.5. Okay, that's good. And let me just find emissive material that I used before. That is not how you write emissive. Emissive instance. There we go. Compile. Save. Okay, we're Gucci. We're back to normal. If I press play, I don't think it's going to give me any errors. Just let me quickly run through this to see. Boop, boop. That's the first one. That's the second one. That's the third one. That's the fourth one. It's now lagging like crazy for some reason. I got stuck a bit. That's good. Going through here. Is it there? It's there. So now it's a super dark part. And then we go to the forest. And yeah, okay. Yay, 32 seconds. My new personal best. Okay. Works without any errors. That's good. So coming back here, view angle. So let's say you want the viewing angle of your character to be slightly larger than it originally is, because originally the viewing angle of the character is 90 degrees, right? So the character can see for 90 degrees. What if you want a slightly larger viewing angle, right? Just to get more information into the screen. Well, you need to change the camera, right? The camera settings of the character. So the way you do it is you find wherever your first person character is in the world outliner, and you click on Edit First Person. Click on that, which again opens up the blueprints of the first person character. So this is the behavior, you know, of the character. If I were to break it down, it's actually super simple. We have mouse input, which is basically when you turn the mouse, it should turn the character. A stick input, this is for Xbox or PlayStation controllers, doesn't matter. You have probably like spacebar and like move forward axis and so on. That's whatever. VR settings if you are doing a VR game and whatnot. And then some additional code to when it begins play, it shouldn't you shouldn't be able to move while the starting screen is showing, right? Then you have event tick. I don't even remember what this does. Oh, race start. Okay. So when you click the mouse button, it starts the race, and when you press enter, it restarts the race. That's about it from the behavioral perspective. Then you have a construction script, which is whatever. We don't care about that. What we do care about is the viewport. So here, when I select the camera in this viewport, first-person camera, it will give me all of the settings of the camera. And the easiest one is field of view, right? This is basically how wide the viewing angle is. So if I change this to original, or even less, let's do less. Let's do like 60 degrees. Click compile, click save, press play. Now I see a very narrow view, right? So now I can only see like I'm almost kind of zoomed in to everything, right? So that's that. If I change this to something super wide, 180 degrees, compile, save, and I press play again. Okay, maybe 180 degrees wasn't a good idea. So this is how it looks like. Wait, let's see if. Oh boy, okay, no. 180 degrees was a bad idea, so let's use something more reasonable, like 140 degrees. Compile, save, play. You can see that everything is kind of zoomed out, and I can see much more, right? So this actually would work if you have a super long monitor, right? Super wide monitor. Even especially if it's curved, it would work. But in most cases, it's just it's like a Quake, that old video game. So Quake used a very, very wide camera angle. So you would feel like you are walking super, super fast in that particular video game. In this case, I would suggest working with values between 90 degrees or between 80 degrees and 110. Because 120 is already a little bit too distorted, so I'm just using 110 degrees. Compile, save, play. You know, that's how it looks like. I think that is fine, right? Right. Then, one more thing that you will notice is mouse sensitivity. I don't know why, but Unreal Engine by default has a super high mouse sensitivity, at least for me. I prefer to have mouse sensitivity quite low for precision. And Unreal has, like, you move the mouse by 1 millimeter and your character kind of turns around. Well, not that extreme, but you get the point. So we need to fix, not fix, but be able to change mouse sensitivity in this overview so that you don't get overwhelmed by the movement. In the first person character blueprint, I'll go to the event graph, and I have already done this, but let me just lie and tell you that it hasn't been done. Yeah, like that. So what you will see under mouse input in the blueprint is going to be this. Input axis turn, input axis look up. So when you move the mouse horizontally, it will turn. When you move the mouse back and forth, it will look up or down. Easy, right? We want these inputs, so axis value, these numbers that it gets from how much of a turning it does, we want these inputs to be multiplied by some number. If it's multiplied by 0.5, that means you need to move your mouse twice as far to look, for the character to look in the same degree, right, in the same angle. So what I'm going to do is I will multiply. So axis value, I'll drag out from there. And you would think that, I just write multiply. But the problem is that it only gives you an option to multiply by pi, which is not great. We don't want that. Instead, what we want is this float x float function. So let me quickly, actually from Rhino, you should already kind of know this. There are two, well, there are more than two, but let's say there are two types of numbers. There are float numbers and there are integer numbers. Integer numbers are like 1, 2, 3, 4, 5, and so on, full numbers. And float numbers are 1.52, 6.582, and whatever, right? So numbers that have fractions associated with them. So float numbers are much more precise, so to say. So this float times float means it just takes a number, a float number, and it will multiply by some other float number, right? So I choose that, float times float, connect that output to the value, and here I will not even create a parameter, but rather here I will just type in what kind of value I want. So the one that works kind of for me, and it might not work for you, but the one that works for me is 0.5, like just half of the sensitivity, of the original sensitivity. You can be cheeky and you can do like 5, and then it's the game is going to be completely unusable because, you know, you basically you just breathe on the mouse and your character starts spinning in circles. So don't do that, please. 0.5. And I'll, since I'm lazy, I'll just Control-C, Control-V, copy-paste, and I'll do the same thing with lookup with the same value, 0.5. That's it. Sensitivity done. I click compile, I click save, just to double check. Actually, I can show you what 5 sensitivity will look like so that you don't need to. So this is 0.5. Let me just move my mouse by like 5 centimeters. So that's something like that. That's 5 centimeters. And then let me change this to 5. Like that. Compile. Save. Let me try to move my mouse by 5 centimeters again. Once it stops counting. Okay, cool. just a blur. Just completely impossible. Actually, I can try to play like this. No. Oh my god. What? Yeah, I can't. It's nauseating. 0.5. Okay, so that is done. That is how you deal with sensitivity. You probably have noticed that we're just doing like these small, we're starting to do these one-off things. And these are, I just wrote down a list of these small things that you might encounter and that in the future or for this project that I find useful to just know. Walking speed, also something that is quite important to be able to adjust. The walking speed is located, you think I remember, oh my god, where is it? I think it's under Viewport. If I select the camera, can I type in speed here? No, that's camera settings. That is not the walking speed settings. What if I don't have anything selected? Oh my god. No, it's not here. Shit. Oh, okay, sure. So it's not even in the blueprint. So we don't need the blueprint for this. We just select the first person character and we, in its details, in the main window, we just write speed and it's going to be maximum walking speed. I have it set to 600. You can have it set to any value you want. The thing is, when you have it like, let's double that, 1,800. Wait, that's not double, 1,200. And we press play. When you have it too fast, then it becomes this kind of a, how do I say, you go through the level so fast that you don't really see anything. Whoa, and also it's super hard to to be accurate. So when you're going fast like Sonic, you don't really see anything. You're just going fast, right? So it's not having a high speed is not great for this instance, because we want people to actually appreciate the environment, right? So I will turn this back to 600. I believe 900 is the default value, so I've just decreased it to 600. That's maximum walk speed. Right. There is one thing that I haven't written here, but that I kind of want to show you. In the first-person character blueprint, there should be like a jump. Nope, there's no jump. Is it in the event graph? Jump. Well, I want to show you, but apparently I can't because I don't know where it is. Could it be just straight up here as well? Then jump. Yeah. Okay. Sure. So it's not in the blueprint. It's actually in the level itself. When I select first-person character, maximum jump attempts. Right. So here instead of 1, I'm using 2, which is basically enabling my character to do a double jump. That's about it. Right, so the character can double jump in the air. I think this is just a little bit of a quality of life improvement for trying to go through this maze, even though it's not realistic, but who cares? And then there is also character movement during the jump. So I already showed you jump velocity. This is how high the character is able to jump. Right? The higher the number, the higher the character can jump. And also air control. This is how much control, how much of the, what portion of the initial control does the character have when he is falling, right? So or when he's in the air. So if you want to give the character more control while he's falling, to kind of steer, you increase this number. I believe the original number is 0.05. Here I amped it up 5 times so that I can kind of steer and control where my character is falling. That's about it. Okay, so that's character movement. Now on to the God rays. So this effect right here, right? These streaks of light, they are called God rays, right? You have fog and you have some nice rays of light shining through the fog. It's nice in the forest. It's kind of also nice inside of the where are we? Inside of the structure, right? Just some nice little effect there. So how do you get that? Well, it's actually a part of the fog, not atmospheric fog, by the way, exponential height fog, this one right here. It's part of exponential height fog settings. So here, when you create an exponential height fog, this guy right here. So basically you create it by drag and dropping it in. I already showed you this during the previous tutorial. When you create it, you can access its settings, and here you have exponential height fog component, where you basically just control the color of it and you control the density of it. That's fine. But the more interesting thing is volumetric fog. This thing right here. Let me just check if I'm not missing anything here. Not really. So much more interesting thing is volumetric fog. Volumetric fog enables you to have these God rays. Let me just find a nice angle to show you. Yeah, that seems good. Maybe a little bit more like that. So here you have a few options. By the way, if I hide it, that's how it looks like. With disable it, this is how it looks like without any atmosphere, without any exponential fog, or rather without any volumetric fog. Sorry, this is with. Scattering distribution is basically the intensity, but you don't want the intensity to be too much. So 0.1, at least for me as a value, works well. It's a lot of calibration. That's the bottom line of it. There's a lot of calibration involved with this, but 0.1 seems to be working fine for me. So I would suggest that you start from that number and fiddle with it later on. Albedo is just basically the color of the fog. I can change this to pink, whatever. Green, that doesn't matter. Let me just change it back to what it was. I don't remember what it was. Yeah, that's good enough. Let's call it that. Then you have, is the fog emissive? Does the fog actually glow? And no, no, just no. It's no. Black color, no. And then you have extinction scale. So this is how intense are the God rays. So if I bump up the extinction scale, you can see that it's quite dramatic, right? If I bump it down to 0.1, there's no God rays whatsoever. I have no idea what I used. I believe it was like something around 1.5. I think that's still way too intense, but stylistically speaking, it kind of works for this particular structure that I was working with. View distance. This is basically how far can you see the God rays. So this is just an optimization thing. And static light scattering. I have no idea what it is, so I turned it off and nothing changed. So I'm just keeping it turned off. Quality teaching right here. Right, so that's volumetric fog. In doing so, you can create God rays. Let us take a look really quickly at my post-processing volume, PPV. I renamed it to PPV. I have two of them. I can actually hide the exterior one. The exterior one doesn't influence the one that's in the interior, but let's just talk about the one that's in the interior. So here, I have the possibility to, for instance, mess around with the bloom, mess around with the depth field, so blurring of things. Don't blur things, they seem to be not that nice. But the bloom itself is kind of nice if you don't, if you don't do this. This might be a little bit, too much. But if you just have a little bit of bloom, that softness of light, I think is quite nice. So I have turned on some bloom. And then for exposure, I am using automatic exposure histogram. And here, exposure compensation, I can decrease the exposure. Well, that is way too much. Let's say 0.1. And it will slowly bring back the light. So I can decrease the exposure to make everything darker, or I can increase the exposure to 10 to make everything maybe a little bit too bright. So that's exposure of 10, and I had just exposure of 1, so I didn't really need to mess around with it too much. Maybe 2 would be nice, or 1.5. Okay, so that's exposure control. Then you have chromatic aberration. Already showed you how it works, right? It's this effect right here. Where is it used? I think it's used in that game that the third version is never showing up. Half-Life 2. It's used in that game, wherever the character is kind of concussed, and also in Skyrim where the character is drunk. Let's just not. Right. Then you have the possibility to have additional camera settings to change, actually changing the shutter speed and so on of the camera, which is kind of nice. Lens flares, so you can add some beautiful beautiful lens flares to your camera. Maybe no. Image effects. I am using a vignette. So this is without a vignette, and let me slowly turn it on. See how the sides of the camera, of the view, they darken? Let me turn it on to 10. Right? So the sides darken while the front stays the way it was. Right? So by using a vignette, I'm using 0.7, a low number. By using a vignette, you are focusing more of the viewer's attention to the center of the view, right? And everything else on the corners become a little bit more dimmed, a little bit darker. I think that is just a nice thing. Then there's grain, which I will not even show you, and then there's depth of field, that's whatever. And then you can do some color grading. For instance, you can change the temperature of your scene to either warm or cold, you know, but maybe doing like extreme numbers like that is not that great. So for instance, I can say that my scene is going to be cold, and also it's going to be tinted towards purple or towards green, I believe is the other side. Yes. So tint is either purple or either pink or green, and temperature is either blue towards blue or towards orange. So that's that. Then you have some global skin, that's whatever, shadows, that's whatever. And you have so many more. It's many things that you can change here, but these are just the main ones that I think are quite useful when you try to make something that is stylistically yours. So you have a full stylistic control, is what I'm saying. Right. What am I missing? Let me check my notes, because yeah. Oh yeah, music and sound. Let me. Is there a way for me to share computer sound? There we go. Share computer sound. Let's just check if it works. Do you hear the click? Wait. Click. Say yes or no. Okay, good. So that's just a sound that I downloaded and associated with the passing of the checkpoint. You can also do the same thing with the level sound as well. So it's all controlled through the tracker first and foremost. When I select the tracker and I scroll down, or rather scroll up, right here under custom settings, these are all of the settings that you have. Don't worry about maximum lapse, gold time, silver time, bronze time, default best lap, default best time. These are whatever, you know, these are just like, I could I could have not added them, but adding them is super easy, so I just added them. So you don't care about these numbers. Name of the map. This is what's going to pop up in the starting screen. So I'm just using creative tools and save game name. So it's kind of saving it is saving your progress, right? Your times into a separate small file. So this is just how it's going to be named, right? So you can change the name of it as well if you want to. It's whatever. No one will see these files. But the thing here is you have level music and you have checkpoint sound. So you can, well, first of all, when you expand it right now, you will just see cloud control and torch pass, like these two sounds. And actually, what you can do is you can import more sounds. So you can do that in the content browser. If you go to audio, this is where you drag in or import the sounds or the level music. I would I must note that it doesn't work with MP3 files. MP3 files are compressed, highly compressed files, and Unreal doesn't like that at all. I believe there are plugins for Unreal which read MP3 files, but we are not using any plugins, so we're not going to use MP3 files. Instead, you can either search for. Let me just minimize that. I'm just opening up the browser. There we go. So we can search for sound effects free WAV. WAV. I think it's like wave format, sound wave format, something like that, right? And you can kind of download the. I don't want to press it, but basically on the internet there's a bunch of free ones that you can get, right? These sound effects, and you can just find whichever you want it to have, whichever sound effect you want it to have when you, for instance, pass the checkpoint. Or if you don't want to have any sound indication that you have passed the checkpoint, you can do that as well. You can just mute the sound. I will show you how to do that in just a second. So that's the first thing. Second thing is there are MP3 to WAV. That is not how you write MP3. Converters, right? So you just drag and drop a file, MP3 file, it sends back to you a WAV file, right? That's as easy as it is. Right? Once you have those files, you just simply drag and drop them into this audio folder, and now they live here. And one important thing that you do need to do, and I have all of them kind of here in this forest, like you do need to actually drag out the files from here into the scene so that they become active, right? So let me actually delete that, break the references, sure, that is fine. Do I have any more sounds? No, I don't. Okay, that's good. So, please don't lag, please stop lagging. Let me just drag them here. So for instance, I will drag in the button switch, right? Drag and drop it in here. I can move it up, and it's basically just an icon that, you know, that shows, you know, this is where your element is located, you know, your sound is located. And also I have, I also have this cloud control music, which is just again a sound wave file .wav, which I'll also drag out here. So this is my music file. This is my button click file. When I select them either here in the world outliner or here on the screen, I have settings for them. So for instance, for button switch, I can use a volume multiplier and say that I want this louder or I want this quieter, right? So I can say 0.5, like half of the volume, right? And I can do the same thing with the music here. I can say volume multiplier 0.3, right? Even lower, something in the background. So we have the sound or the music and the sound effects kind of in our scene, and they are we have controlled their their sound levels. So now it's time to add them to the game itself, and it's done through Tracker, as I mentioned before. Tracker, we scroll down here, level music, we find, for some reason I have two of them. Do I still have? Yeah, oh crap, I have the original one, didn't delete the cloud control, the first one. So back in Tracker, I just choose cloud control as my level music. And for checkpoint sound effects, I choose button switch. That's it. When I press play, now it's going to have some sort of a... This is some random song I just downloaded from the internet. So it's going to play the music for us. And also do the clicky. If I don't want to have any music at all I need to do is just mute it, right? So I go to my cloud control, that's the name of the song. I find that, and volume multiplier, I just set this to 0. That's it, it's muted. Is there like a mute button as well? No, there's no mute button, but basically I just changed the volume multiplier to 0, and that's done. Okay, that is all about sound. Let's move on. I just need to do this real quick. Foliage mode. Go ahead, yeah. Yes, that is correct. Oh, inside of the structure and outside. That's an interesting idea. Oh, so it wouldn't be like a wind, some sort of wind sound effect or anything like that, but it would be just the footsteps themselves, right? That's interesting. Yes, of course it's possible, but I don't know one part of it. I don't know how to attach it to the first-person character movement speed, meaning that meaning that you move super slow, but the footsteps are so I need to investigate that. I need to take a look at that. But yeah, that is definitely doable. Can you track sounds to specific objects? Yes, you can. For instance, a checkpoint, the glowy floaty boy, it can do the whoa, whoa, whoa sound as well. And I could show you that, but the problem with it is that it will become problematic in the long run in terms of the blueprint, the behavior blueprint of the checkpoint, because we will need to not just hide the geometry, but we will also need to mute the sound once you pass through the checkpoint, for instance. If it's not the checkpoints, if it's associated with more static objects, for instance, you know, the geometry of the level itself, that is definitely doable. That is definitely something that we can do. I will need to... I don't want to do it right now because I need to prepare. But I will show you next time. Hello. Absolutely, yes. That's it should be a gradient. The closer you get, the louder it becomes. So that's for sure. Yeah. That's actually the main thing that I will investigate. How do you control the size of that gradient, or the influence of the, at which point do you start hearing it, right? Do you hear it when you're behind the corner, right? Or do you not? Or do you hear an echo of it? Do we need to calculate the echo? If we do, then is there a plugin for that? Because that's, I'm not going to code it. It's a little bit out of my expertise. So there's a lot of things that I need to research, but you'll need to wait in terms of sound for the next Thursday, so that I can give you a decent example. I just removed the flowers from there. They were bothering me too much. All right. That sound, let's call it, let's call the intro to the sound done, but there's more things to investigate. Then we have, oh, right. When you do, right now, the way this level or this program works is when you will run it as a separate entity on your computer, there's no quit game button, right? So, and also it kind of automatically runs full screen. So it kind of soft locks your computer, and the only way you can close it is using Alt F4 combination. I don't think that's a great user experience. So I will just quickly show you. We will script a really quick function where when you press the escape key, it actually closes the game. Because right now, when I press play here and I press the escape key, it does get out of that play game mode, but it just gets out of the mode. It doesn't. There's no functionality associated with close the game that says to close the game. So the thing that not the thing, but what we need to do is we need to change the blueprint of the level itself. So this is like the highest, let's say the deepest level of control that you can possibly have of the scene is within the blueprint of the level. So like behavior of the world, right? So we will access it not through here as we usually do, but rather by going here to blueprints and clicking on open level blueprint, clicking on that. And let me just delete that. So what you will see is just empty, nothing, right? No functionality in the world that is kind of overriding every other functionality. So here, I want to say when escape is pressed, quit the game, right? Two functions. First one is when escape is pressed. I right-click inside of this level blueprint and I type in escape. Keyboard events, escape key, right? Easy. Click that. That's our escape key. And what can happen is you either, when you press it, it will register, or when you release it, it will register, or there's, yeah. Either when you press it registers, or when you release it registers. And then from it, so when you press it, it should register. From it, I'll drag out a wire, and I'll type in quit game function, quit game. Super hard script, we're done. When you press escape, it quits the game. Compile, save, close. Okay, and we are kind of done. Last thing that I want to show you is how to actually build it or package it, so that a person who's using or who's viewing the game or the environment doesn't need to have Unreal Engine installed. So under File, there's this Package Project option. Package Project. And here there's like, you can package it for Android phones, you can package it for HoloLens, iOS. Wait, iOS is for iPhones, right? It's not for MacBooks. No, for MacBooks it's just macOS. So there's a little bit of controversy going on between, like a little bit of friction going on between Unreal and Apple right now, because of Fortnite and Apple Game Store and so on. So they are kind of fighting each other. So there is no option to export it to macOS. I assume that this is why it is. But you can export it to Linux or for Windows. Before I click here, I will choose my build configuration to not be for development purposes, but rather for shipping purposes. Development is basically for insider testing. So development configuration is when most of the stuff that is being packaged, you can still access it as if you were in the content browser, as well as there's like debugging information going on. Shipping is basically presenting it to the client, right? So I'm choosing build configuration as shipping, and then I'm choosing on Windows 64-bit. Clicking on that. And now what it's going to do, it's going to start packaging, compiling. I think it's first going to build all of the lights, all of the materials, and everything, and make sure that everything kind of works. It's going to save everything. It's going to ask me to give it a folder. So I'll just say new folder, whatever. Just save it there. It's going to give me a small sound indication, and basically, yeah, it started packaging, right? Show output log. Basically, when I click on show output log, it will show me everything that is going on. In most cases, you have no idea what this means, but if there is a problem, it will give you an error here. There was one thing that we didn't do, and that thing is, let me cancel this real quick. Yeah. It didn't like it. It didn't like it at all. So there is one thing that we didn't do. See where it says here, lighting needs to be rebuilt? We need to build the lighting, right? So before you package, you use either build lighting only, or I prefer to just use build, and it kind of rebuilds the whole scene and makes sure that everything is consistent and nice, and then you package it. When you package it the first time, it takes an hour on my computer. I don't know how long it's going to take on yours, but it takes like an hour. This is for the first time. When you make changes and you package it the second time, it takes like 5 minutes, maybe less, because it remembers what what kind of decisions it needed to make before in the first time, and then it just kind of redoes just the parts which have been changed, right? So it's quite an optimized system. Once you're done with it, let me find it. Once you're done, it's just going to say packaging completed, and you will get this kind of folder in which you will find your application, which you can run. And that application is going to contain your game. I will run it in just a second, but let's just look at what else we have here. We have two folders, engine, binaries, third party. So this is like, actually, let's not go through every folder. It basically just packages everything that particular game needs to work, right? So if I run it, yeah. Development. So you should always, at least I always package it for shipping. So it is going to be always, I believe if you package it for development first time and then second time you package it for shipping, it is going to be faster. Like it is still going to remember from the last time when it packaged for development. But personally, I always just use package for shipping. It just seems to work. Yeah. The only difference is the development version is a little bit bigger. And also in the development version, when you go into the folders of the game, you get more access to different assets and so on, so you can see more what's going on inside of the folder structure. When you package it for shipping, it's everything is hidden from the user so that people can't crack it and leak it on Pirate Bay, for instance. So let's do that. The reason why we do it is because it's smaller, right? That's the only reason. So this is, whoa, boy, recording and having Zoom running is not going well for my laptop. Either way, seems to be working quite well. Click, click. Oh my God, got stuck. Click that, that. Where are you? I need you. There we go. Up. Oh, that's a nice lag. I can just assume what kind of PowerPoint presentation you are seeing on your side of the screen. You know, just blurry lines all over the place. But this is just me testing out if, oops, that's the wrong turn. Oh my. Okay, let me just hit escape. So I just hit escape and it closes the game altogether.